Hi everyone, welcome back to the channel. In today's session, we will deep dive into how you can connect virtual networks VNets using a VPN gateway connection in Azure. If you are in a scenario where security, encryption, or even connecting overlapping address spaces is critical, then VPN gateway connectivity might be the solution for you. We are going to explore the architecture, key advantages, and configuration challenges for using a VPN gateway, especially in comparison to VNet peering. So let's get started. Unlike the simplicity of VNet peering, which uses the Microsoft backbone for low latency connectivity, VPN gateway establishes a secure IPsec IKE tunnel over the public internet. This introduces a trade-off. While you gain advanced encryption and security, you also have to contend with higher latency and increased setup complexity. When you provision a VPN gateway, keep in mind that it takes significantly longer to deploy, up to 40 minutes, depending on the size and complexity of your VNets and the gateway SKU you choose. Now, why would you opt for a VPN gateway instead of VNet peering? The answer usually lies in compliance and security. VPN gateway VPN gateway connections encrypt data in transit, which is a critical requirement for industries bound by strict regulations such as HIPAA or GDPR. This makes VPN gateways an ideal choice for organizations that prioritize encryption over low latency connectivity. Beyond security, VPN gateway connections also allow you to work with overlapping IP address spaces using the NAT gateway rules. This is a lifesaver when you are integrating legacy systems or merging networks that weren't designed with collaboration in mind. There are two primary connection types we'll cover today. The first one is VNet-to-VNet connection. This option is perfect if you're connecting VNets within the same subscription or Azure AD tenant. The configuration is streamlined because Azure handles much of this setup, including automatic routing updates if the address space of a VNet changes. This simplicity makes VNet-to-VNet connection ideal for intra-subscription communication. The second one is site-to-site IPsec connection. The site-to-site IPsec connection is a bit more involved but offers greater flexibility. This method is best suited for more complex setups like when you need to connect VNets across different subscriptions or Azure AD tenants. It requires manual configuration of the local network gateway in each VNet, which gives you more control over routing and security. One of the key trade-offs with VPN gateway connections is performance. Unlike VNet peering, which offers private high-speed connectivity, VPN gateway connections route traffic over the public internet, inherently introducing higher latency and lower throughput. The performance of your VPN connection will also depend on the SKU of your VPN gateway. For instance, a basic SKU might be suitable for development or small scale environments, but production workloads will likely require higher performance SKUs like ultra performance. Security is a standout feature of VPN gateway connections. By default, traffic between VNets is encrypted using IPsec IKE, ensuring data privacy and compliance with industry regulations. Additionally, you can apply network security groups (NSGs) to filter traffic and control access between VNets. This is particularly useful for enforcing isolation and security policies in a multi-VNet architecture. One of the standout benefits of VPN gateways is the support for overlapping address spaces. This can be crucial when dealing with legacy systems or networks that weren't designed to work together. By using NAT rules, you can map conflicting IP ranges, allowing communication between otherwise incompatible VNets. In summary, VPN gateway connections offer powerful encryption and flexibility, especially when working with regulatory requirements or complex network architectures. However, they introduce additional complexity, longer setup times, and higher latency compared to VNet peering. If your use case involves compliance, security, or integrating legacy networks with overlapping address spaces, a VPN gateway connection is an ideal solution. That wraps up today's walkthrough of VPN gateway connections for inter-VNet connectivity in Azure. If you found this video helpful, be sure to like, subscribe, and hit the bell icon to stay updated with more cloud architecture insights. If you have any questions or scenarios you'd like to discuss, drop them in the comments below. Thanks for watching, and I'll see you in the next video.